everyone, good day. Welcome to our very first lecture presentation under General Chemistry 1. So this lesson is titled Matter and its Properties. So without further ado, let's get started in our lesson. For discussion overview, I will be discussing two major areas under the matter and its properties. First is that we will discuss the study of chemistry. So we will view the study using two levels of perspectives. So these are the macroscopic and the microscopic perspectives of understanding chemical systems. And then I will also discuss the properties and different states of matter. These properties here includes physical and chemical properties, extensive and intensive properties as well. So we will be differentiating these types of properties. And also, under the classifications of matter, we will learn to recognize what pure substances and mixtures are, the difference between elements and compounds, and then also how to distinguish among heterogeneous and homogeneous mixtures. So let's go here, the study of chemistry. So the chemistry, it is the study of matter and the changes that matter undergoes. So basically, what chemistry is talking about, or kanang iyang major, will be the study of matter. So as a quick overview, chemistry, this is the branch of science that deals with the composition, structure, and properties of matter. And then by definition, matter is anything that occupies space and volume and has a mass. So this includes the things that we see and touch, anything. So it could be water, it could be trees, or even wood, anything that has that occupies space and volume and has a mass. And then it also includes the things that we cannot see, especially the air. So it's also a type of matter that chemistry is studying about. So the study of chemistry, this involves two levels of understanding. So these are the macroscopic view and the microscopic view. So to start with the macroscopic perspective in understanding the the understanding chemistry and the matter that it involves. So we have three phases of matter. So we know these are solid, liquid, and gas. So for solids has fixed shape and volume. So it is independent in the size of the container, meaning it does not follow whatever the shape of the container na it is put there or it's inside. So it is also incompressible because the solids are usually very hard objects. And then for liquids, it takes form in the container, as you can see in this diagram or picture. So sorry. So it also forms a horizontal surface, horizon, and has fixed volume. So liquids, they are dependent on the container, and they are also incompressible type of fluid because the liquids tends to move if you try to compress them. So it's very hard to compress liquid. And then gases here, they expand to fill the container. So gases, they don't have fixed volume and shape. They are also they are also compressible, but it's easy as compared to liquid and solid. So they are compressible because the atoms and molecules usually in the gases are much more spread out than solid and liquid. So if you try to compress the gas, so most volumes of the gas is composed of large amounts of empty space between the gas particles. So when you try to compress them, the particles will move closer towards each other. So Matter is observed through two types of description properties. So these are the physical properties. And for physical properties, you could determine this if the property of the matter cannot be changed, it can be determined without changing the identity or the composition or structure of the substance. So under physical property, it also divided into intensive or extensive properties. So if the physical property that you're going to determine can be dependent on the amount of the substance. So if it is, then it's the extensive properties. So example for this, we have mass, volume, and weight of the matter. And then if this property does not depend on the amount of the substance, so meaning we have here intensive properties. So it's innate or it's being present already on the specific type of matter. So example for here, we have density, color, luster, odor, malleability, conductivity, hardness, ductility, boiling point, and melting point. So here are other examples for intensive and extensive properties. Then we also have the thing called chemical properties. If the properties that we try to measure for matter are they are can be determined by changing the identity of the substance. So, example for these chemical properties are the toxicity of the matter, its oxidation states, its heat of combustion, chemical stability, flammability, coordination number, reactivity, possible chemical bonds, and enthalpy of formation. So matter is also observed through two types of changes. So we have physical changes and chemical changes. For physical changes, these are it occurs when a substance alters its physical properties, but not its composition. So an example here is that when ice melts, so what it's a water in solid state. Then when it melts, it becomes in its liquid state. As you can see, there's a change in its physical property. So from solid, it becomes liquid, but not its composition because the composition of the ice to liquid water is still water. So this is an example of a physical change. For chemical change, it causes a substance to change into an entirely new substance with a new chemical formula. So here, water, if it's introduced to electric current, it produces to, or it decomposes into two different types of atoms, which are the hydrogen and the oxygen atoms. So here is an example because as you can see, there's a different formation from water. It transformed into two new substances, which are the hydrogen and oxygen. So this is an example of a chemical change. Now we look uh, the study of chemistry, into microscopic or particulate perspective. So first is that um, in looking into matter, is mainly composed of unimaginably small particles called atoms that retain the chemical identity of the element they represent. So usually atoms here, um, these are the smallest. These are the smallest unit of ordinary matter that forms the chemical elements. So every solid, liquid, and gases is composed of either neutral or ionized atoms, and these atoms are extremely small in size and is not visible if we look at it. So we also have element. Element is composed of atoms that with identical physical and chemical change. So when we say element, this are type of microscopic type of, of, of groups of atoms. They cannot be separated into simpler substances by chemical means. They have the same properties. because mostly are composed of only one type of atom. So another one is molecules. So molecules, these are groups of atoms held together by attractive forces whose properties are distinguishable from those of the individual elements. So these molecules, they are not free elements. They are group of atoms bonded together. They represent the smallest fundamental unit of chemical compound that can take part in a chemical reaction. So in this uh, in this diagram here, you can see different combinations of atoms, but let us determine which among them are elements or compounds. So or molecules, I mean. So here, this hydrogen, oxygen, phosphorus, and or tetraphosphorus and octasul octasulfur, these are all elements because they are composed of atoms with identical physical and chemical properties. So when we say identical physical and chemical properties, only one type of atom. So here for each two gas, we only have one type of atom, which is hydrogen atom. For O2, we have oxygen. For tetraphosphorus, we have four phosphorus atoms. And then for octasulfur, we have eight sulfur atoms. So for water and carbon dioxide and this glucose, these are example of molecules. Why? Because they are separate groups of atoms that are bonded together. So as you can see, for water, you can find a oxygen atom, and then you can also find two moles of hydrogen atom. So na-combine sila together to form water. And then also carbon dioxide, we have one carbon atom and two oxygen atoms. And same also for glucose. We have six carbon atoms here, the black ones, 12 hydrogen atoms, and six oxygen atoms. So these are examples of molecules. Now we go to the microscopic perspective in looking at three phases of matter. So for solids, particles maintain a regular ordered shape or structure. It maintains size and shape. So for solids, as you can see here in this picture, so for solids, the the particles are very closely packed. So the interparticles here are so small that if we try to bring them closer, there's repulsion starts between their electrons. So they are considered incompressible. For liquids, the particles remain close but no longer ordered. So usually it takes the shape of the container. So um, here in this picture also for liquid, they are considered incompressible. Even the molecules are already close together, but they are not that close as compared to the solid. So it's more difficult to compress them since it could cause the spreading of the molecules. For gases, these are particles that are widely separated and move independently from one another, and it also fills available volume of the container. So for gases, the atoms, as I mentioned earlier, the atoms and molecules are more spread out as compared to liquids and gases, but it's um, easier to compress them because uh, the most of the volume of the gas is composed of large amounts of empty space between the gas particles. So when the gas is compressed, the particles are forced closer together, and it's very easy compared to liquid and solid. Now we go to the different classification of matter. So all matter, all matter are classified either pure substances and mixtures. So pure substances, these are also known as substances which consist of only one type of substance present and can be classified as either elements or compounds. So each component or substances in a certain mixture retains its chemical identity because mixture, this is composed of one or two more substances present. And then each component here, they retain its chemical identity, even if you tend to react them into other types of matter. So here, example for elements, we have uh, oxygen, hydrogen, and iron. So they are pure substances because they are composed of only one type of atom. And then also for compounds, we know that these are composed of one or two types of atoms. We have example here like water, table salt, and even ammonia. For other for mixtures, we have example here. For example, coffee. Coffee is an example of mixture because coffee is composed of three components. So we have coffee, water, and sugar. So these three components has retained its chemical identity, which means that even if you dissolve them together, the coffee, the composition of coffee is still coffee, and the composition of sugar is still sugar, and the composition of water is still water. So for mixtures that have uniform composition, these are called homogeneous mixtures or solutions. So when you say uniform composition, it has the same proportions of its components throughout in a given sample. So usually, example for homogeneous mixtures, we have salt water, mouthwash, and all different types of alloys. Then for heterogeneous mixtures, these are mixtures that have non-uniform or irregular composition. So when we say irregular composition, it doesn't have the same proportion of this component throughout in any given sample. So example for this, and it's pizza, Italian salad, dressing, solid waste dump. So as you can see, the proportion of its composition, it's yeah, you can see it. It's very visible in appearance. So for example, problem 1, let's try this. Which of the following diagrams represent elements and which represent compounds? So each color sphere here, or truncated sphere, it represents an atom. So I'll give you 5 seconds to answer this. It's very easy. 5, 4, 3, 2, 1. Okay. So uh, we could answer this problem. So for which among them is elements? So for letter B and D, these are elements because as you can see, we could see only one type of atom. So even though they are composed of one or more types, one or more atoms, but they are the same. So that is still an element. So for compounds or molecules, these are examples of this. So as you can see, there are two types of atoms bonded together, and usually these are the characteristics for compounds. Now we go to example problem 2. We classify each of the following as either pure substance or mixture. So, okay, I'll give you 10 seconds to answer this problem, then we'll answer it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so here for water, this is a pure substance because it's a compound. It's composed of two elements, I mean two atoms of oxygen and one atom of hydrogen. We also have a soft drink, which is a mixture composed of sugar, additives, and water. Then for mercury, this is pure substance or element, and carbon dioxide also is a pure substance because it's a compound. So it's composed of CO2 or two atoms of oxygen and one atom of carbon. For bronze also, this is a mixture, but usually bronze is made up of copper and tin. And copper and tin are they are elements, right? So It's considered mixture because the composition of bronze and on copper and tin to form bronze is it's only small amounts, so it doesn't cover entirely the whole atom for this mixture. For air is that it's homogeneous mixture because it's composed of uniform composition. For practice problems, I will let you answer these two problems here. First is define physical property and chemical property. So identify each type of property in the following statements. First is yellow-green chlorine gas that attacks silvery sodium metal to form white crystals of sodium chloride for table salt. And then a magnet separates a mixture of black iron shavings and white sand. For number two, which of the following is a chemical change? Explain your reasoning. So first is boiling canned soup, toasting of sliced bread, and then chopping of love, and lastly, burning of blood. So that ends our lesson for today. So thank you for listening. If you want to reach out and send your answers, so you can send your answers here in this email. And then thank you for listening, and I hope to see you on the next lecture video. So, thank you.